Good afternoon. Today's job is to work on multiplying and dividing by powers of 10. So the goal really is to look at the patterns and save a lot of time just by counting. So if we look at the powers of 10, what does that mean? Well, basically there are 10 as a base and different exponents on that 10. So 10,000 is 10 to the 4. You could put billions, trillions as different powers of 10. When you have fractions, they can also be considered by powers of 10 because the 10 in the bottom of a fraction refers to negative exponents. So for example, 1 over 10 is the same thing as 0.1, means the same thing. And that can also be written as 10 to the negative 1, as we saw when we did the expanded forms. So 1 over 10,000 is 0.0001 or 10 to the negative 4. Hopefully not too complicated, and realize that we're going to try and use these patterns to our advantage. So quick check here. Which ones of these are considered to be powers of 10? 10 to the something. Well, a million is 10 to the 6. 10.0 is simply 10 to the 1. This one should clearly be a power of 10. But 0.011 is not a power of 10 because you would split it into two different powers of 10. So that one doesn't count. You can't just write it as 10 to the something. Same thing with the 20,000 or the 1100. You cannot write those as just 10 to the something. What about 0? Can you write that as 10 to the something? The worst we see is 10 to the 0 is equal to 1, but no, this doesn't happen either. So the next three, though, are powers of 10. This would be 10 to the negative 2. This would be 10 to the negative 5. And if you count the number of decimal places, that kind of gives you the clue on how that works. And this is 10 to the negative 2 because it's got two decimal places over. Now, when you want to multiply by powers of 10, we have to use the base 10 system to our advantage. If you multiply by 10, the number is going to get bigger. If you divide by 10, the number is going to get smaller. And basically, we're going to do this by moving the decimal place to the left or to the right. And the idea is you have to tell yourself, is it going to get bigger or is it going to get smaller? So when you're multiplying by powers of 10 that are big powers of 10, you move the decimal to the right because the number is going to get bigger. And you move it the number of decimal places equal to the number of zeros that you see. It's a matter of counting. So here's a few examples going on. Multiplying by 10, 100, 1,000, or even 1 million, you would move the decimal over 6 places if you're multiplying by a million and put in all those zeros that were necessary. This is a skill that's going to become very important later on when we do scientific notation. Now, when the powers of 10 are written as exponents, it's even easier because the 1 or the 2, the 3 or 6 tells you exactly how many decimal places to move to the right. So let's try these ones. Picture where the decimal is going to move. Is the number going to get bigger? Absolutely, in all three cases. Let's move the decimal over one place, is going to be 38. Move the decimal 3 places, it's going to become 3800. Move the decimal 7 places, well, you're going to count that 8 as one of the decimal places, so you're going to have to put 6 zeros on at the end of that. 38 million. And then 3.8 times 10,000, uh-oh, you got to count now. 4 places. Whoops, what's going on there? 3800. Hopefully not too painful. A couple more difficult examples where we mix them up a little bit. You can take a look at these and see that it works to your advantage, that it works the way you would expect it. Remember, big powers of 10, the decimal moves to the right. Take a couple of seconds, you can pause to look at those. Now, when you're dividing by powers of 10, the numbers are going to get smaller. Okay, so dividing by 10 or 100 or 1,000, or 10,000 or a million, you're going to slide the decimal to the left this time instead of the right. And the exponent, or the number of zeros, tells you how many places to move that decimal. So try these ones. You're dividing by 10 to the 4, it's going to get 10,000 times smaller. So the decimal is going to move 1, 2, 3, 4 places over. Remember, the decimal, if you don't see it, is always written on the right side of the number. And generally, we try to put that extra 0 as a blocker in front of the decimal. 10 to the 0, hey, don't move the decimal at all, because 10 to the 0 is just 1. 10 to the 2, okay, so it's basically two zeros, is going to move it decimal 2 decimals smaller, 3.75. And this one's going to move it 9 decimals smaller. So you're dividing by 1 billion. You're going to slide the decimal 3, 6, 9. Okay, so we put those decimals in place and the leading 0 out in the front. Hopefully not too complicated. Here are a couple more difficult examples because you've got to either count the zeros or look at the exponent and recognize where the decimal is when you're starting off. So same deal as before, we can pause and double check that you know how these things all work. Notice, by the way, in 0.45 at the end here, we don't need the extra zeros anymore. Multiplying by powers of 10, negative exponents. Remember now, if you multiply by a negative exponent, that's a small number. And so it's the equivalent of dividing, actually. You're going to do the opposite of what the positive exponents would do. So let's take a look, okay? You would move the decimal to the left the same number of times you see in that multiplication because it's a negative. And basically, you can just sort of tell yourself negative means left. So try these ones. You're going to take multiplying by 1/100th, right? That's the same thing as dividing by 100. So the decimal is going to move 2 places to the left. Multiplying by 10 to the negative 4, you're going to move the decimal 4 places to the left. It's all about patterns. Take a pause. Make sure you can figure it out. Now, when you divide by powers of 10 that have negative exponents, this is where it gets a little bit confusing. It's like, what is going on? Well, you're dividing by a very small power of 10, and so the number's going to get bigger. It's like a double negative, okay? So dividing by 1/10 is basically saying how many times, well, basically, if you were dividing by 1/10, it's going to get 10 times bigger. 1 place to the right. Dividing by 10 to the negative 2, it's going to get 100 times bigger. Just tell yourself, okay, this is the weird one, and hopefully you'll remember it that way. Negative exponents do the opposite of what a positive exponent does. So here's some more difficult examples to try. You're dividing by a negative power of 10, and you know what? Some students take the time and they say, well, sir, that's the same thing as 27.69 times 10 to the positive 1. It is. It's exactly what's going on. Okay, so if you can recognize that and maybe rewrite it if it's easier, no problem. So good luck finishing those questions off.